with the least risk and with the most peace. For me, and I love real estate. I got a bunch of it. But for me, I'm selling that rental in about 30 days.
Yeah, me too. And that's where I feel like the risk.
The big thing for me is trying to get the ball. He would have had an easy double play because it was right at him. He just missed it.
Now here's Reyes, the big right-hand hitter, to knock out deep.
Wow, part 3. Mike, are you ever going to get this regen working? Well, we have to finish up our wiring. We have to wind a coil, and then we need to test the stages one at a time. And you guys would like to hear what's coming out of the radio. You know, at these low voltages, you're just barely able to get enough audio into a headset. But in order to drive a speaker, we're going to need a little bit of external amplification. I've seen many circuits on the internet and in books, and they'll tack on an amplifier, like an LM386 or an LM390 or 380. I think I'm going to dig out that old 1U5 3V4 battery amplifier that I made. That runs on 35 volts and a 1.5 volt AA. I think that would match this nicely. And that's going to allow you guys to hear what's going on with the radio without straining our ears too much. So this is part 3, low voltage regen. So I was reminded by one of the people that watch the videos that this is a beginner's project. Let's not get too complicated. And why don't circuits work? When you build something, you pound your head against the wall and it doesn't work. It's usually one thing, but sometimes it's a multiple of things and you get frustrated. You solve one problem after another and the radio still doesn't work. It's probably best with any project that involves a headphone, such as an amplifier or a radio receiver, to start at the headphone side, or start at the end of the circuit, not at the front. Don't start at the antenna. Start at the place that you're listening, which is your earphone or your headphone. So this is the cord set that goes to this set of Federal headphones. And of course there's 2 elements, one for each ear. And those 2 elements go into these 2 cords, and they get put in series and come out these 2. And we call these 2000 ohm headsets, okay? So just for fun, let's try to measure the DC resistance of each element. See if we can get on there. Aha! 1004 ohms. Okay, and on the other side, 1051 ohms. So if we put those 2 in series, we basically have 2000 ohms of DC resistance. Now, the AC impedance, or the AC resistance of these headsets, are much higher than 2000 ohms. But when we're talking about things like crystal radios, it's the DC load on the crystal that really limits your volume. So you do have to have a very high AC impedance, but you also have to have a high DC resistance. So these would be appropriate headphones for our regen. They're going to give good sensitivity. They're high impedance headphones, so I'll put those back together. Here's a set of Baldwin phones. These are the famous moving coil headsets, quite sophisticated for the early teens of the 20th century. Let's see what we got for impedance with these old corroded 1.4K. That's as low as I can get on there. 1.4K DC resistance. However, we will find that these have much more sensitivity than the Federals. Even though they have a lower DC resistance, they're going to give you more audio output. So, interesting. Here's a military headset from World War II. This is, when you're flying your B-17 over Germany, this is what you want to use. So let's get on each element here. That may be an easy way to measure these if we haven't got good continuity. Okay, 113 ohms on that element. And 126 ohms on that element. So 200 ohms DC on these. These would not work well on our Regen or a crystal set because they're low impedance headphones. They're considered 600 ohm headphones. So you would have to use a transformer on the output of the Regen that would convert the 7 to 10,000 ohms down to the 600 ohms for these headsets to get good audio output. So these are not appropriate without a transformer. So what about my Sony Walkman headset or my Beats earbuds? Or let's measure those and see what we got. $34 ohms. So these are definitely going to require a transformer to work at all. These are the worst choice of all for your Regen. First thing you need to do is measure your headphones. And look, I had a couple of these headphones that weren't measuring properly. You're going to run into the same problem. So before you complain that nothing's coming out of your Regen, make sure that your headset works. That's step one. Boy, that dining room's an echo chamber. It's time to look at the schematic. Yeah, I've been avoiding this because I wanted to go through some of the basics before we started in on the schematic. Plus, I didn't actually know if it would work or not. I mean, you can publish a schematic, but that doesn't mean that the circuit actually works. And I wanted to prove it to myself and be confident that at least the 24-volt version worked okay. So on the left we have a very conventional Armstrong type regenerative with the 12AT6. And I did find that the 12AT6 worked a lot better than the 12AV6. And I would suspect that the 12BF6, like the 6BF6 that Morgan picked in his original article, was not by accident. It seems like the lower the gain, or the GM of the tube, the better it works in some of these simple Regen circuits. So keep that in mind. Also, when you wind the coil, and you wind the tickler coil the same way you wind the main coil, one direction, and they're both in phase, because the tube has a 180-degree flip, you will have to flip the tickler leads. So I've drawn it that way just to call attention to that fact that you think you're winding it right and you hook it up to the schematic, and guess what? It never works. Well, the reason it never works is it never can. You have to flip the tickler leads because the tube inverts the signal by 180 degrees. I picked a pretty stout C3 throttle capacitor because we're at a low voltage and we need a little more bypassing to get enough feedback. Also, when we get to the coil design, you're going to see that the tickler coil is about 2 times larger than normal. That's because at these low voltages we need more feedback. I decided to go with the conventional choke for this first circuit, and you can buy one of these chokes from Mauser, made by Hammond Manufacturing. A 20 Henry choke will give you over 40K of resistance at 300 Hertz. So you're going to get plenty of impedance, and I think that this will give you the least voltage drop, and allow the circuit to work at lower voltages, say 12 volts instead of 24. Then we go into a very straightforward voltage amplifier to drive the headphones, and I actually put some bias on the cathode. Even though this is extremely low current and the chance of overloading the tube is slight, I decided to put a little bit of bias on there just for good practice. In the next section we're going to be completing the wiring, and we're going to be winding the coil. Okay, drill the hole large enough for the shoulder washer. And then you're going to put the shoulder washer in. That shoulder washer is going to fit the phone jack. Now in the back, you only need to use a flat fiber washer. You don't have to use another shoulder washer because this one's going to set the distance to the metal. Okay, now we have the flat fiber washer on the back, and we're going to install the jack so it's peeking through. Okay, it looks pretty good. There's just enough room to get a nut and maybe a thin lock washer on the front. And now we've just tightened the front. We have the lock washer and the nut on there, and we have our insulated phone jack on the front panel. So we want to make sure that the jack is truly insulated from the front panel. So I've inserted a plug. I'm going to touch all of the terminals on the jack. We have no connection to the front panel. Totally open circuit. This is also a good time to determine the two connections that you want to make with the jack. This particular jack has a shorting feature. You want to make sure you're hooked up to the right two terminals because it can get very confusing if you don't have that. Well, I hope that this pictorial diagram is a help to you when you're starting to lay out your circuit. I know I've been kind of going straight forward without discussing the wiring that much, but I wanted to get the schematic developed first. Now this is showing the wires as straight lines. I've seen a lot of guys that tend to wire their circuits much like they string their guitar. In other words, the straighter and tighter the better. That's really not the idea here. I've also seen people go out of their way to make the circuit so pretty that the wire ends up being 3 times longer than it needs to be. I think for RF practice we need to kind of take a middle of the road approach and make the wires in such a way that they're generally following a straight path back to where they have to go, but they're not stressed and they're not wandering all over the place. I did use some different colors here to help you out, and if you trace the wires it's going to help you to follow the schematic, and there's some practical grounding tips in here too. So let's see if we can wire this thing. So this is the most sensitive part of the audio circuit. It's the input to the audio amplifier, pin 1. As you can see, I'm shucking a wire into the shield. Okay. Now to make that easier, I've folded the end of the wire over, so it's kind of a slippery thing, and it's not going to catch on the shield. So the radio frequency choke isolates that RF connection and keeps any of the RF from getting into the audio chain. So it's just an isolation component. The radio frequency choke can be anything between 1 and 10 or even higher millihenries, but we'll make a compromise choke on a sewing machine bobbin. Now there's a little hole in the end of the bobbin. That's where you bring the tag end out. You just go back and forth, filling that bobbin up. Well, the bobbin's basically filled up. That's as much wire as we can get on there. That's going to be our radio frequency choke. Again, 30, 32, or 34 wire would give much higher performance than this number 28 wire, which is too thick to give a lot of inductance in a small winding like this. So I've got a pretty good size tube here. You know, this is a little bigger than you normally use. It's a full 2-inch diameter tube. And with the AM band you need to have about 100 turns on there. So by using a little bit bigger tube, I can back off on the turns a bit. I'm using number 26 enameled wire. Number 24 would be fine as well. The thicker the wire, a little bit better Q. So let's, I've got holes drilled here because it makes it easier to anchor the wire. We should probably start with the most difficult winding, which is towards the middle. This is going to be the primary. We're going to do this first. And I'm going to start with about 80 turns on there, and we'll work back from that. And then this is the tickler winding that's going to be here. So we'll do that second. I've gone through, in and out, and I'm actually going to wind against this so that it's harder for the wire to pull out. So I'm going to start the winding not this way, but the other way. Okay, 8, 9. Winding coils is another one of those touchy subjects in the world of homemade radios. The simple solenoid style winding that we're doing with close turns, not too much emotion there. Everybody agrees that you want to put a little gap between the tickler coil and the primary. So I'm picking a 1/4 inch, 6 or 7 millimeters between the two coils. Now, how you hook those leads up is interesting. We would like to put the ground at the very top. And we'll get into the why having the ground up top a little bit later when we start to add the coupling coil to the secondary coil. So the main coil that we're winding is called the secondary. The primary we don't have in this particular radio. It could be a coupled link. We're going to come right off the secondary with a trimmer capacitor to the antenna. But in the future we're going to put a primary coil on there, and that wants to be at the very top. So that's why we're leaving space up there. So we have the ground of the secondary coil at the very top, and then down at the end, that's where the grid leak is connected. Then we have the positive side of the circuit, which is actually RF ground. Okay, next. And then we finally have the plate at the very bottom. So this is going to give us a good coil for the regen. I went over a little bit before why we flip the leads on the tickler coil if we wind the coil in the same direction for both winds. Now, if you wind them in antiphase, in other words, you wind the secondary coil one direction and then start the tickler coil the other direction, then it works with the original schematic that you're used to seeing. Okay, this is the first time I'm firing up the radio, and I'm using a simple trimmer off the tune circuit to go to the antenna. We can get a little more sophisticated later, but this is a kind of the Morgan version of dribbling some signal into the regenerative receiver. I've got some good news. There were no major mistakes with the wiring. The volume control and the regeneration control both work in the right direction. The tuning is not bad. With my 80 turns of wire on the 2-inch form close wound with number 26. My low end is around 450 kilohertz and my high end is around 1400 kilohertz. So I'm a little bit low, so we're probably going to have to remove about 10 turns. So instead of 80 turns, it's going to be more like 70 turns on the primary. I did get feedback, not as much as I expected, and it turned out that the first 12AV6 tube had low gain. I stuck in a 12AT6 and immediately got pretty good regeneration. So I also noticed that increasing the coupling capacitor, the bypass capacitor on the plate for bypassing the tickler coil probably should have been raised. I put a 250 picofarad cap there. I stuck a 680 in there, and it went into regeneration across the entire band with 24 volts. So, of course, I have not increased the number of turns on the tickler or brought the tickler coil closer. At this low voltage, I think we may have to adjust the tickler coil to get enough feedback. What I am noticing that is disturbing, though, is that the audio sounds very tinny. It sounds very restricted and high, and so we need to investigate and see if that's possibly the choke is not a high enough value to allow the full audio to come through the lows. And we also want to investigate if our homemade choke is in any way affecting the frequency response. The 0.01 capacitor with that 1 meg pot, there shouldn't be any loading there at all. That should be plenty good for normal listening. So I'm not ready to let you hear it yet. I will rig an amplifier to the headphones so you can listen to it. So as I listen to the Regen and make comments about, oh, it doesn't sound right, or I don't like the way the control is working, or it's hard for me to translate that into something that we can listen to. And the way I've done that up to now is by using an LM386 type of amplifier set for a gain of 20, which roughly gives you the same effect of putting earphones on. So I thought I would use my old 1U4 3V4 amplifier, which runs on a 1.5 volt AA cell and a 36 volt supply. It's an old HP supply from some kind of printer. And by using I'm just using a 27K resistor to simulate my headphone, and running the B plus right through that. And this is allowing me to hear what's going on.
Correct. We also have $50,000 saved in our
So
bank account.
And
now,
that'll make you 100% debt-free,
this
house
is a
and cars.
this is a strong station. It's WBZ Boston. It's strong in the headphones and it's strong in the speaker. So now we have kind of an equivalent type system. And I can tell I don't like what I hear.
$1,000 emergency fund and then $30,000.
Pay off the house and still be sitting there with a pretty decent-sized emergency fund. So here's the way that the two of you can decide.
Now it's very intelligible, but I don't like that it has no low end. And what we're seeing is that choke that we were making out of the audio transformer is probably not giving a high enough impedance to give good performance. So one thing we're going to try right off the bat is replacing it with a resistor, or maybe another choke of a higher value to see if we can get the audio to sound right in this thing. So for many of you that make projects, perhaps this was a successful project for you, but I don't think we're done yet. I think one more video is in the pipe. We need to try some different tubes. I'm seeing variations between the tubes that I've tried so far. I actually had one tube that was regenerating as low as 6 volts on the plate. Ordinary tubes. So we would like to try to tame this beast and see if we can come up with a very solid circuit. Also, we haven't tried 12 volts yet. We've been doing everything with 24 volts. In the next video, let's try some 12 volts and see if we can get the Regen to work as well as it does on 24 volts.